So when we started this unit on Monday, we talked about trying to figure out what the zeros were or what the solutions were for a graph. So we looked at a graph. We had our axes. We said, okay, what if my graph intersects here and here? So we had a graph that looked like this. And we had these points where it intersected, and let's say that that's at 1, 0, and that's at 4, 0. We called those our solutions to that quadratic or to that parabola. They can also be called what we call the zeros. They're essentially the solutions when whatever that formula is, that quadratic formula is equal to 0. Well, we're not always given the graph. We don't always have access to the graph. Sometimes we're just given the equation, and we want to be able to solve that equation. And we're going to do that today by factoring. In order to factor, though, before we get to that point, we have to introduce a property that's called the zero product property. What that zero product property says is it says this, that if I take two things like A and B, with A and B being two separate things, if I set that equal to 0, so A times B is equal to 0. If this happens, one of two things has to happen. Either A has to equal 0 or B has to equal 0. I suppose both of them could be 0. But as long as one of those two things is 0, I have a true statement because 0 times anything is 0. 5 times 0 is 0. 0 times 5 is 0. As long as one of those two things is 0, then we've made that a true statement. So you put A and B in there, and A and B never means anything to really anybody but mathematicians. Students look at it and say, yeah, what? We don't see things that just are A and B. We see things that maybe say x times x plus 4 equals 0. Okay, so we've got something that's factored. We've got something like you looked at the other day, yesterday. You had one that was like x times x plus 4, but now we're setting it equal to 0. The power of kind of the zero product property, and the zero product property is used throughout mathematics. Kind of it's one of those things that never goes away, like factoring, never goes away. What the zero product property says is that if I can set one of these pieces equal to 0, or find the value that makes it 0, I have a true statement. So I can think of the x as my A, and I can think of the x plus 4 as my B. So this is my A, this is my B. The zero product property says then that either x has to equal 0. That was what I said was kind of like the A value. If I say x is equal to 0, plain out x is equal to 0. If I substitute it in there, that's 0. That's 4. 0 plus 4 is 4. 0 times 4 is 0. I've got a true statement. It equals 0. Or part B has to be equal to 0. Part B is x plus 4. That has to equal 0. Well, this I have to solve. It's kind of a one-step equation that you have to solve. I have to figure out what number plus 4 is equal to 0. Well, mathematically, that means I subtract 4 from both sides, and you get x is equal to negative 4. So those are my two solutions to this problem. 0 times 4 is 0, makes it true. If I have negative 4 times negative 4 plus 4, that's 0. Negative 4 times 0 is 0. So both of those things then become my solution using the zero product property. Graphically, what does that mean? Graphically, that means if I were to draw this parabola, and I'm not going to draw the whole thing because I'm not 100% sure what it looks like, I know that it has to cross the x-axis at 0 and -4. At the minimum, I know that it has to cross my graph at those 2 points. Now, it might go up, it might go down, it goes up. Okay, it's going to go in this upward direction. We could find the axis of symmetry and we could do all those things. We're not going to. But we could, actually pretty easily, do that. But that's what it means when we're finding the zeros. We're finding out that intersection along that x-axis. And this is the zero product property. A times B equals 0. Either A has to equal 0 or B has to equal 0. Okay? Let's look at another example. Let's say that I have something like 7x plus 4 times 2x minus 3 is equal to 0. And I want to solve that equation. It's factored for us already. It's saying that if I take 7x plus 4, if I can figure out an x value that makes that 0, or I can find 2x minus 3, I can find something that makes that equal to 0, I've got a true solution. So that's what we're going to do. We're going to set the first one equal to 0. The first set of parentheses, 7x plus 4, I'm going to set that equal to 0. Now we have an equation that we can solve. Now it's a two-step equation, 5th grade standard, something you've been doing since 5th grade. How do I solve that equation? Well, I have to subtract off 4 from both sides. If I subtract 4 from each side, that leaves me with 7x equals -4. Divide both sides by 7. One of my solutions is -4/7. That's one of them. So again, if I replace this -4/7 in for my x value, that's going to give me -4. -4 plus 4 is 0. I don't even care what this side is. Doesn't matter. Because 0 times anything is 0. I'm not even going to bother to put it back in there because I don't care. Plus it's a fraction. Don't want to do that. Too much work. But it doesn't matter. The first part is 0 already. We move on. Now we set the second part equal to 0. 2x minus 3 equals 0. Again, two-step equation. We've been solving since 5th grade. Add 3 to both sides. That gives us 2x equals 3. That's a nice 3. Now it's a 3. Let's do a little bit better in the handwriting department. Divide both sides by 2. Divide both sides by 2. Be lazy, be like me, and just circle it and say it's 3/2. Okay. That's my second solution. X is equal to 3/2. So either of those things, -4/7 or 3/2, is going to give me a true solution to this equation. Okay. Using what we call the zero product property. Question so far? Try it on your own. Let's go n plus 7 times 2n plus 1 equals 0. Go ahead and solve that equation. It's already factored for you. Don't have to factor it. It's already done. See if you can find the zeros for that. About 20 more seconds. So one of two things has to happen. Either n plus 7 equals 0. What's the solution for that? negative 7. Or 2n plus 1 has to equal 0. Subtract 1 from both sides. Divide by 2. Negative 1/2.
Or this one, we could put this in there.
Leave it as negative 1/2. Don't even mess with it. Leave it as fractions. Algebraically, we like fractions. In algebra, we like fractions. We don't like decimals. Okay? Now, here's the thing about the zero product property. It doesn't matter if I do 2 things or I do 4 things. We just had if A times B equals 0. Well, if I have A times B times C times Z times D equals 0, if I can make one of them 0, it's a true statement because 0 times anything is 0. Okay? So, here's how I look at it. It can be a lot of writing sometimes, or you can just look at it and ask yourself, what makes that 0? 0. What makes that 0? Some of you can just look at it and say, negative 7. If you can't look at it, you just say, okay, well then x plus 7 has to equal 0. Subtract 7 from both sides. X equals negative 7. If I look at that one, what makes that 0? 3. Again, if you can't do it that way, set it up. X equals 3. What makes the last one 0? Negative 8. So here are all 4 of your solutions that if you plugged one of those solutions in, it's going to work. Whether you can answer the question in your head or where you have to write the equation down, you do what you have to do. Some of you will be able to look at this today and say, boom, 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 boom. I don't need to write all those equations down. I can see that the answers are 2. And I can see that the answer is negative 1/2. That's where I hope all of you get to eventually. And eventually what I'll ask here next week is I'll just simply ask, what makes that 0? Just like I did up here. Don't expect you to be experts at that at this point, but it's something that you can just kind of start looking forward to, and there's things you can do. And some of you can do it already. Do it. Okay. Now, what happens if it's not factored for us? What if we have a quadratic equation like v squared minus 9v plus 18 equals 0? Now we've got pluses and minuses in here. So it's not, I can't set v squared equal to 0, 9v equal to, I can't do that because it's not a zero product property problem yet. But it's a quadratic. It's like what we did yesterday. Omit all of this stuff, and we did that yesterday by factoring, and that's what we're going to do today for the second part of it. Is we're going to say, okay, now we've got a quadratic like we had yesterday. How do we find its solutions? Well, we find its solutions by 1, making sure it's in standard form first. Standard form means that you have everything on one side of the equal sign and it equals 0. If you think about the zero product property, the key word in there is 0. It has to equal 0. If this equaled 10, you can't do it until you set it equal to 0. Then you can use the zero product property. Okay, so that's the first thing. You got to get it in standard form. It means you got to get it equal to 0. Also, a value, positive. Now we're going to factor, just like we did yesterday. So we're going to put our x value. We're going to put our x on the top, 18. On the bottom, negative 9. All the problems you have today are going to have a leading coefficient of 1. Tomorrow we'll put leading coefficients other than 1. So I need 2 numbers that multiply together to be 18 and negative 9. So it's positive on top and negative on the bottom. That means both of them have to be negative. 6 and 3. So that's v minus 6 and v minus 3. But now it equals 0. So now we finish it. V minus 6 has to equal 0. Add 6 to both sides. I'm not going to show that. You should be able to do that. So V is equal to 6. Okay, I'll show it. Plus 6 plus 6. Or V minus 3 has to equal 0. Add 3. V is equal to 3. And those are your two solutions. Those are the solving of the equation. We call them the zeros. Again, you don't have to do this part today. Just remember what it means. It means that our graph intersects our x-axis at the point 3, 0 and at 6, 0. And this graph is going to look something like this. Let's look at a second one just sort of like that. Let's go x squared plus 5x minus 6 equals 0. Step 1, make sure it's in standard form. Check. Standard form, again, means that everything is on one side of the equation, generally speaking on the left, and it equals 0. Done. A value is positive. Good to go. Now we're going to see if it factors. Hopefully it factors. Will these always factor? No. Will they over the next couple days? Yes. Eventually we're going to introduce the quadratic formula. That's next week. Late next week. We've got negative 6 and 5. The top is negative, so that means one has to be negative, one has to be positive. Always. Anytime that top number is negative, one's got to be negative, one's got to be positive. What are they? Negative 1 and positive 6. Negative 1 times 6 is negative 6. Negative 1 plus 6 is 5. Works. So x minus 1, x plus 6. But again, it equals 0. Zero product property then says that x minus 1 equals 0. Add 1. X equals 1. Or x plus 6 equals 0. Subtract 6. X equals negative 6. Boom, boom, boom. Done. Those are your two solutions. 1 minus 1 is 0. Perfect. 0 times anything is 0. Negative 6 plus 6 is 0. 0 times anything is 6, 0. We're good. Okay. So far, so good? All right. Then the next type of question we're going to look at is we're going to say, all right, what if I have something like n squared minus 5n is equal to 14 in like 4 minutes, because that's about how much time we have left, maybe 5. What do we have to do first with this? Put it in, say it out loud. Standard form. Got to put it in standard form. So we have to get the 14 to the other side of the equation. How do I do that? I just move it. So say it. Subtract 14. I'm going to subtract 14 from both sides. So I'm left with n squared minus 5n minus 14. I can't combine that with anything because they're not common terms. Now I've got it in standard form. Now see if you can finish it off. Give you about a minute. 3, 2, 1. Negative 14 and negative 5. So one's negative, one's positive. Solutions are?
Negative 2 and 7.
Negative 7 and 2. Because we got negative 5 on the bottom. So then we've got n minus 7 and n plus 2. That equals 0. What makes that 0? What makes n minus 7 0? 7. What makes n plus 2 0? Negative 2. Okay. There are your two solutions. Last one. So now let's go with x squared equals negative 13x minus 40. And I'm going to let you do this one by yourselves from the beginning. I am going to warn you, move everything to the left. You want your x squared to be positive. Remember, first step is put it in standard form. So move everything to the left. Okay? Give you about 2 minutes for this one. Eight and 5. All right, if you peek up, you see the solution up there? See how you did? Should have got answers of -8 and -5. Okay. Any questions so far? All right, last little thing here, and this is, we're gonna look for observations. So I'm gonna highlight this right here and this right here. And I'm gonna highlight this down here, and I'm gonna highlight this down here. What do you notice between the red and the yellow? The numbers are just opposite. Here's the thing with this stuff, okay? If you notice, we've got -7, +2. Our solutions are 7 and -2. It's the opposite of it. We've got 8 and 5. We've got answers of -8, -5. They're the opposites of it. This always happens. Okay? You need to show all of this today when you're doing your work. You need to show the zero product property because I need you to understand and know that you understand the zero product property. But you can check your answers. Look up here. And when you get down here, they better be the opposite of it. If it's not the opposite of it, you're going to be in trouble. So always check. And here's the thing we're going to do tomorrow. Tomorrow our A value isn't going to be 1. Tomorrow A value is going to be 5 or 7 or 12. And you know, we've always done, I'm not going to write it on there, but like today we had something like n-7 halves and n plus 4 halves or whatever when that leading coefficient was A. Tomorrow what we're going to do is instead of dividing it at this point, we're going to divide it at this point inside of here. We're going to put the division here instead so you can see your solutions to these. Okay? We'll work on that tomorrow. 12 questions on your practice work for today. The first 6, they're already factored for you. Use the zero product property.
I have a question for number, yeah.
Second 6, you have to factor. If it's just a binomial, if it's just 2 terms, take out a GCF. So if you have P, so if you have P squared plus 8P, take out a P. So then you've got P times P plus 8. You can still use the zero product property for that one. Okay, look at that. Even knew which